So we just want the overall, the net reaction. So did somebody get it? The magnesium nitrate. Well, first off, what's the formula for magnesium nitrate? Mg NO3 parentheses 2. That's correct. Magnesium is 2 plus, nitrate's a 1 minus. We'll need 2 nitrates for every magnesium. And water. Oops, not water. What is it? Plus ammonia. Well, the thing is, ammonia is in the solvent water. And the solvent, the major component is water, or the major component is ammonia? Water. And so there's plenty of water around. Do we need that water? Yes, we need that water, because this is called hydrolysis. Hydrolysis is reacting with water to break it apart. And so we need magnesium nitrate plus ammonia plus water. What forms? Magnesium hydroxide and ammonium nitrate. Okay, well, maybe use that other reaction. There are 2 ways of doing this. Is know this, or 2, what we do is we just envision that hydrolysis reaction occurring. And when the hydrolysis reaction occurs, what forms? Ammonia and water react to form a little bit of ammonium and hydroxide. Well, why don't I just erase ammonium water and replace it with ammonium hydroxide? Well, if I did that, you might get the wrong impression. It's like, why don't I just erase food and write pyruvate instead? Is that okay? No, it's not okay. The same thing as this. It's not okay to erase this and write ammonium hydroxide, because ammonium hydroxide comes from the acid-base reaction of this. And so what we're doing is we're combining the Bronsted acid-base reaction with the metathesis reaction into one equation, and this one equation is going to be the overall reaction. So if somebody asks you, well, what about the metabolic cycle? Well, do you want to write every single step of the metabolic cycle out? No. And so the same thing here. We react this, and we're going to form this. So what's the driving force for this? Precipitation. Is there much driving force for this? There's not much driving force for this. But we got to remember Le Chatelier's principle. Le Chatelier's principle says even though we aren't going to form much hydroxide, in fact, we're going to form minimal amounts of hydroxide, we're always going to form more, because as the hydroxide is being consumed in the metathesis reaction, Le Chatelier says this is going to shift to the right, meaning, in fact, we can form a lot of hydroxide. We just got to keep removing it from the reaction. So even though it seems like, yes, we got a driving force here, but we don't really have a driving force here, what we do in that sense, in the sense of Le Chatelier's. All right, so we got driving force, which is precipitate, and therefore we should balance this. To balance this, what do we need? 2 ammonia, and 2 waters, which is going to form 2 ammonium hydroxides, and 2 ammonium nitrates. And so this is what we call the CE. Let's go to the IE, the ionite equation. What do we do with the magnesium nitrate? Do we leave it or ionize it? Into okay, do we leave this or ionize it? Well, this is a common mistake. People will ionize it. They'll go 2 ammoniums plus 2 nitrates. Well, it's not really a mistake. In fact, not 2 nitrates, 2 hydroxides. They'll go 2 ammoniums and 2 hydroxides. It's not really a mistake, but the problem is you don't go and buy ammonium hydroxide. You go out and buy ammonia. And so we don't want to get the misimpression that we're going to have that. And so we're going to leave it as Yeah, this will be 2 ammonias and 2 waters. Fully aware that, yeah, those have to react first before we can get hydroxide to do this. Magnesium hydroxide, do we ionize that or leave it? Leave it. It's an insoluble salt. Insoluble salts we always leave. This will be MgOH2 solid, and then ammonium nitrate is a soluble salt. So what do we do with soluble salts? Yeah, we ionize it to 2 ammoniums and 2 nitrates. Okay, so that would be our ionic equation, and then we go on to our net ionic equation. The net ionic equation, we'll get rid of the spectators. What's a spectator? Nitrate. Nitrate. Any other spectators? No. Ammonia is not, because on one side we have ammonia, on the other side we have ammonium. Ammonia and ammonium are 2 different things. One's a base, the other is an acid. So we got magnesium ions plus 2 ammonias plus 2 waters. This is going to produce magnesium hydroxide solid plus 2 ammoniums. And so this would be our NIE here. So that's the example of the metathesis reaction. Okay. So that's a little bit of review for equilibrium, acid-base, metathesis. We also did Lewis acid-base. We did one example of a Lewis acid-base reaction, which involved the reaction of what and what? Anybody remember the Lewis acid-base reaction? Involves CO2 and water. CO2 and water is different than ammonia. Ammonia and water, that's a Bronsted, but CO2 and water, that's a Lewis. So a bit different. And not only that, CO2 and water is an acid. Ammonia and water is a base. Okay, then we went on, I went through these chapters quite quick, so this is why we're going to do little reviews here and there. But we went on to redox. One of the big applications for redox reactions, batteries. Batteries, they have another name. What's another name for a battery? Another name for a battery is the voltaic cell. Voltaic cell. Let's make a battery. We're going to make a battery where we're going to put the oxidizing agent. The oxidizing agent will have its copper. Let's go with copper nitrate, copper 2 nitrate. And then our reducing agent will just be, this will be aqueous. Our reducing agent will be solid zinc. Okay, what I want you to do is I want you to sketch the voltaic cell for this. So why don't you spend a little bit of time and come up with the best sketch you can for this battery. You know, try to detail how the battery operates. You do that?